So monomials can include, these are things that are monomials. Number,
Guys, shut up.
variable, and the product of numbers and variables.
Numbers, variables.
And the product of number and variables. So when you look right here in this box, this would just be a number, and a number, right? Is the first row. But then notice the second row is now variables also. And notice that we're multiplying, because when you have a number next to a variable, that means that it's indicating multiplication, right? It's indicating that you take whatever that variable equals and times it by the number that's already present. Remember that from algebra?
Hold on. Repeat that.
Yes.
Okay, when there is a number next to a variable, this is implied multiplication.
Okay.
Oh, yeah.
Okay, yeah. Alright, I got you. I didn't hear it the first time.
Y'all remember that? Alright, now, these are things that are not monomials. Okay? This, and this are not monomials. They're actually binomials. Okay? They are binomials. Okay? So, binomials are...
Can y'all stop talking?
Alright? Non-monomials cannot... A non-monomial is a number with a variable that you are... There's a variable under the radical. Radical is a fancy word for what? Square thingy, a square root. Okay? A radical is a word for square root. Or any kind of root. It could be the third root, the fourth root. Okay? You cannot have a variable in the denominator. If I have a variable in the denominator, what kind of function is that?
Wait.
A variable in the denominator, what kind of function?
Not switch.
Rational?
It's the NO, right? There's O.
That's when you're talking about simplifying with a zero and slope. If I have a variable in the denominator, what kind of function is this?
Radical.
A rational.
Rational.
This is a rational. Okay? Alright, next. Last thing is that you cannot be adding or subtracting.
No, I don't do
Okay? Addition or subtraction. So, a monomial cannot have a variable under the radical, a variable in the denominator, or addition or subtraction. Okay? Words that you should be comfortable with and not freak out when you hear are a constant. Constant is a word that you should be familiar with. A constant is a monomial with no variables. So when we look at this box up here of monomials, which monomials are just constants?
the top three.
The top three, right? So it would be 2, 5/3, and negative 8.5. Those would be just constants because they do not have a
And 0.
variable. Oh, is 0 up there too?
And square root of 5, right?
And square root of 5. Okay? Now, the next word that you need to remember is a coefficient. A coefficient is the numeric factor of the variable or the variables. So in layman terms, it's the number in front of the variable. Okay? So the number in front of the variable is your coefficient. It's the number in front that has the implied multiplication. So when I look at the box of monomials,
So the second row
the second row
and the one in the middle of the third.
and the one in the middle of the third, those are my
Coefficients.
Coefficient. So is it okay if I just write the 2 of 2x as my example?
Yeah.
I put it in there, I circled it too.
Okay. I don't know what I just wrote right there. I meant to write etc. Okay? So the coefficient is the number that has the implied multiplication with it. Okay?
This is ETECT.
Oh my gosh.
Are we gonna have to remember this?
That's that girl.
You're just going to know that if I use that variable,
Who is that?
Brittany,
Dr. Robinson.
No, I mean like whenever you take a test over this, we're gonna have to memorize all that stuff.
yes, because they're going to be implied in questions. So if a problem says, what is the constant? You need to say, oh, the constant is. If the problem is asking about looking at the coefficient, you need to know what the problem is telling you to look at. It's only 2 words, constant and coefficient.
No, I mean like the top two, like we have to memorize that too.
Yes, if I gave you a quiz over what's a monomial and what's not a monomial, you should be able to say, yes, it's a monomial. No, it's a monomial. Yeah. Does that make sense?
Yeah, I think I got it.
I think this is a monomial and this is not.
If it's all in the top box, they're all monomials. Right. All right, next we're going to go on to the degree. So we're going to go on to the degree of the monomial. Okay? The degree of the monomial is the sum of the exponents on the variables alone. Only on the variables. Only on the variables. Got it? It's the sum only on the variables. So look here. When there's a variable by itself and there's no visible exponent, its exponent is 1. So therefore, the degree of this problem is
1.
1. Got it?
Got it.
Yeah.
Wait, I didn't get it.
Exactly.
So the degree
Listen.
of there's only one degree of the
Oh, okay, I got
The
it.
sum
Okay.
only on the variable.
Okay? So
No.
here,
2.
on this one, my degree is
2.
2.
on this one,
2.
2.
3.
How?
Why is it
Oh,
3?
X and Y.
There's 1 and a 2, which equals,
3.
so my degree is
3.
3. It is a third degree monomial.
So this one is 12.
So this one would be,
12.
so it's a 12th degree monomial.
0.
Why 0?
Because there's not one.
There's no variable. If there's no variable, can I have a degree?
No.
No.
So if it's a radical thing.
What if it's
No,
a
there's.
degree?
It doesn't matter that it's a radical. It matters that there's no variable.
What if there's a degree on just the 2? It's still 0, right? Because there's no.
It's a number, not a variable. Okay?
Ooh, you want to do all this on this
On the back. Ready? Okay. Back in 8th-ish grade, when you learn this, you were probably taught to expand. To expand and combine like terms, right? So when you expand and combine like terms, what that means is that you take all the numbers and you get them into their prime form. You take all the letters and how many ever exponents there are, that's how many letters there are, right? Okay? So when you did that, it came down to, now when you're multiplying, you just multiply.
Wait, I have a question. Why couldn't we have just added the y's and that?
We're getting to that point as to where you've evolved, Heaven.
Why is there I thought it was kind of stupid. Why started out?
Huh? Okay? Now, let me go over this again. When you were in 8th grade, this is what they were teaching you to do, right? Now, the reason why there are 2's in there is because you have to take the numbers down to their prime form. And the prime form of 4 is 2 times 2. So I would do 2 times 2 times 5, which is what?
20.
And then I will count how many x's I have, and that would be my exponent. Count how many y's I have, and that will be my exponent. Okay? But now, because we're at this level of awesomeness, we know that all you have to do is actually multiply the coefficient. And all you have to do is add the exponents. Correct?
Yeah.
That's where we're at. Am I caught up to you now, Heaven?
Yeah.
Oh, okay. All right, so what's the rule? The rule is when I'm multiplying exponents and they have the same base, the base, that is the same as saying a to the m plus b n.
Ooh, 8 to the E.
Okay, did y'all leave Algebra 1 understanding that?
No.
No.
Semi.
But no.
It's gonna click in a few minutes.
Wait, put it back on.
I'm thinking.
It'll click once you teach it again. No, please.
All right.
When you be too late?
Excuse me?
When you be too late?
They'll have like
No?
5 minutes.
But there's 2 A's.
Huh?
There's 2 A's.
No, that's not what the rule says. The rule is that's your base, and you're only adding the exponent.
So the 1 minute.
All right, here we go.
To the 1 minute.
So here we go with dividing. With dividing, they taught you the same thing. Take your numerator, expand it out. So you would take the number, find its prime factorization, expand it out. And then it's okay. Now, if the number of the variables in the numerator and the denominator, you get to
Cancel out.
cancel out. So 2 and 2 would go away. 3 and 3 would go away. X, and then 2 y's, because I have 2 y's in the denominator. So what you have left
3 A's.
X, 3, Y.
3 plus Y.
times y.
X2.
Divide and subtract.
Oh.
Okay? Now, hopefully you left algebra with the idea like, oh, instead of having to do all of this, all I'm doing with my coefficient is dividing. And all I'm doing with my exponents is
Adding.
subtracting.
Oh.
Ooh.
Yeah, because you took away.
Okay? So the rule is if I'm dividing two numbers or variables and they have the same base, that means that in essence I'm taking the exponents and I am
Subtracting A.
subtracting them.
And then M minus.
Okay? I know there isn't an example for you on here, but I'm going to give you an example. So for example, if I had x times 2 times x to the 6, what would that be?
X to the
X
6.
to the 8.
X to the 8. Because 2 plus 6 is,
But why here do we subtract? Oh, we added. I'm sorry.
we're
So
multiplying.
we multiply. So we gotta add. Now if we do X.
Now, on this side, if I get to teach, if I had a to the 12 divided by a to the 4,
It's A to the 3.
No, it's not. 12 minus 4 is not 3.
a to the what?
8.
8.
To the.
Don't get caught up with actually dividing.
Oh, I thought we divided. Oh.
No, that's why I did this problem. Don't get caught up like, oh, 12 and 4, that's 3. No. What is the rule? You subtract. So 12 minus 4 is 8. Do we get it?
Yeah.
All right. There are additional rules that we need to cover that you should know. So the first rules that we're going to cover, we're going to do the rules and the samples, and then I want you to do the practice ones. Okay? All right. So before we do that, I just want to go over one that's not up here. The rule that's not up here that I want you to add to the bottom. The rule that's not up there that I want you to add to the bottom is x to the 0
Equals 1.
equals 1. So no matter what it is, if it's to the 0 power, it equals uno. So if I have this problem and it said 5 to the 0, what is 5 to the 0?
Uno.
Do we get it?
Yes.
Anything to the 0 power is 1.
Uno.
All right, so let's go over our other rules. The other rule right here, I call this the bad number rule. It's not called that. It's called a negative exponent rule. Okay? The bad number rule. So this variable or this number, this base, has been a bad number. So in order to teach it a lesson and to make it into a good number, you send it to the basement. Okay? So it's been a bad number. In order to teach it how to become a good number, you send it to the basement. And because it's becoming a good number, its negative goes it becomes a positive.
So you put a 1 on top.
Is
Yes.
the one like the opposite of like what it is?
Yes.
So like on that one it'd be like 2, a positive 2 over.
So on the
5.
sample here, what would it be?
1 over 5, 2. Yeah.
Which becomes what?
1 over 10?
5 squared is 25.
I'm sorry.
Okay?
We have to
But I
solve.
got it now.
If it's a number that you can, go ahead. Okay? Does that make sense? So it's been a bad number, and we want to make it into a good number. So we send it into the basement so it can learn its lesson and become a positive number. All right. If you don't like my analogy, come on with your own. All right. This one. This is when you're distributing exponent. So we are distributing an exponent. When you are distributing an exponent, you are actually multiplying.
Wait, on the top, can you do the last one? Last example.
In a second.
Oh, we're gonna go back.
Okay? This is distributing. When you distribute, you actually multiply. So when I go to the sample, I'm going to distribute, and I have 5 to the 6. Anyone knows what 5 to the 6 is? What is it? 15,625.
Ooh, get him.
Sorry, Caleb. Sorry.
What's this?
Okay?
Yeah.
Again, when you're distributing, and it's a fraction. So when you have an exponent and you're distributing into a fraction, you are still going to multiply. You're going to distribute to the numerator and to the denominator. So I'm going to distribute this 2 to the numerator, and I'm going to distribute this 2 to the denominator, and I get 25 over
16.
64.
I mean 64, sorry.
Calculator girl, use it.
They look at us. Sorry.
All right? All right. Next is distributing when there are multiple variables inside. When you distribute and there are multiple variables on the inside, you're going to distribute to each variable. Okay? To each variable or to each coefficient if there exists.
So it's 25x4.
So this is going to become 5 squared x to the 4, which equals,
25 to the 4x's. Something like that.
okay? So for the rest of the class period, I want you guys to do the last 8.
Can you show me that other one?
It was 5 2 8.
I'm sorry.
It was 5 squared 8 times 8 squared.
Ooh, killer.
Nah.
Yo. Oh.
Oh, there's one more rule, I'm sorry, that we need to add it.
Oh my Jesus. So many.
We gotta take a test of these. All of these rules. I'm gonna be confused.
The last rule that I feel is important, but they don't emphasize, is when you have a negative exponent.
Oh, she didn't do that. That's another.
Okay, when you have a negative exponent already in the denominator,
Oh, you want to
that means it wants to be rebellious. It doesn't want to be down here. It wants to escape and go to the, it wants freedom.
Oh, so you move it?
So you just put it back like the other one.
Wait,
Like on the top.
you what? So this one will equal x to the nth power?
Yes, so if I had 1 over a to the negative 3, that equals what?
A to the negative 3.
No, a to the
A to the
third.
positive 3.
A to the third, a to the positive 3, a cubed.
So on this one's gonna be x to the 4.
Huh?
On this one?
On your,
On the top. X negative 4 goes to
it's been a bad number, so it's going
down.
To the bottom.
to the bottom.
But this
So
one at
it's
the bottom
one-
is already
1 over x.
So he's going to escape.
So it's gonna be 1 over x.
So this is going to be 1 over x to the 4.
You leave it.
Yeah.
Okay?
Wait, can you help me with B3 over B9?
Okay, well first, what does that mean you do?
Subtract.
So 3 minus 9 equals,
Where I was 4. I don't know.
X.
Yeah.
to bad B, where does it go?
Yeah.
Bottom.
I barely got it.
Ooh.
Got it.
It took me a while.
I'm ignoring y'all. Alright,
Sorry, Nick.
so this is multiplication because it's distribution, right?
Oh my god. That's the bone.
Guys. Please.
What's next? What would this one be?
B minus 12.
B minus 12.
Oh,
And then it goes back to the bad B.
1 over b to the negative 12.
And then 1 over B12.
Okay. What about this one?
oh, x7 over y7?
Because it's distributing into a fraction, so I distribute to the numerator and
And then
Denominator.
x6, y12.
Are you gonna be here for tutorial?
yes.
And that one's b15 over c
We have you all practice today, right?
No, 120.
I can do this.
Yes, sir.
Yeah.
Do we have you all practice today?
Yes. I think it's just gonna be you.
And then that one is x2 y15.
What is this one?
X6.
x6,
Y12.
Okay. And the last one?
I didn't do that.
Miss Ware, what is
64x6 y12.
Okay, so it would be 4 cubed, x to the 6, and y to the,
12.
which equals 64 x to the 6, y to the. Should your homework be hard?
What about the promise?